Let's talk a little bit about a merge sort, and again, just the concept, not really doing any coding or anything, but there's a deck of cards here, and it represents my array of numbers, 8, 5, 2, 6, 4, 7, 9, and 3. And this array, if you will, array of cards, is not in order. I would like to sort them in order. Now, a merge sort basically works in pairs, and this is the easiest example that I could use, is just to have maybe a group of 8 array of length 8. And so it works like this. It takes pairs at a time. Like this 8 and this 5 is a pair. The 2 and the 6 are a pair. The 4 and the 7 are a pair. And the 9 and the 3 are the pair. And so what it does is it basically puts each pair in order. And so it orders the 8 and the 5, and it swaps. It says, do we need a swap? The answer is yes. So it's going to make a swap and put those in order. And it kind of keeps track of those as a pair. Then it looks at the next pair and asks, do I need to swap? The answer is no, and I do not need to do that. So then these would stay in this order. So the 2 and the 6 will stay in order. And we'll move on to the next pair and ask the 4 and the 7. And there's no swap needed. So the 4 and the 7 stay in their positions, but they stay as a pair. And then the 9 and the 3, that needs a swap. So the 9 and the 3 get swapped and stay together as a pair. So that's the first pass on a merge sort. It basically just sorts each pair. Now, once it finishes the first pass, it has to go on, and it now joins 2 more pairs. But we have to remember now, right now we have a pair that is like one list, or why should I say one array of numbers. We have another pair. And what merge sort does is it takes this pair, because those are in order now, and it merges those. So it will take those and it will merge those together. So the 5, 8, 2, and 6 all merge together and swaps get made where 2 is the smallest. It needs to go to the front. 5 would be the next card. And it would need to, it would need to go next. And then we have the 6 would slide into place here. And the 8 will slide in after that. I might have to change that one too. So that is these two orange or yellow or gold pairs get merged together now. And the same thing happens over here with these two orange, yellow, or gold pairs. These get merged together. And so the 3 needs to be sent to the front of the array or the list. The 4 would be next. And then the 7. And then the 9. Okay, and we now have just 2 things left, if you will, or 2 sets of cards left that we need to merge. So now we're going to merge those 2 into one big array. So these get merged together and a bunch of tests are made, and 2 will slide in front. The 3 is next. Then the 4 slides into place. Then the 5. Then the 6. Then the 7. Then the 8. And there it is. And then the 9. So it's kind of interesting. This is really actually a math problem where it's powers of 2 here. Notice the boxes are doubling as I go up this diagram. But as you can see, we take our original list and we take the first 2 items, merge them together, the next 2, merge them together, the next 2, merge them together, the next 2, merge them together. That's pass 1. And then we take, now think of it this way, these 2 items and merge them together. They become this. And these 2 items, and we merge them together, and they become this. And then we move on, and we then take 2 items, which are now these 2 items, and we merge them together to become the final array of sorted elements.